Alright, for our first day working with logarithmic properties here today, we're going to look at the problems we did yesterday in class where we had problems such as log base 4 of 132. And you did a bunch of these yesterday. If you remember, the question is asking 4 to what power will give you 132? Well, I put the question marks there because this one's confusing to me, because 4 to the first power is 4, 4 to the second power is 16, 4 to the third is 64, 4 to the fourth is 256. So therefore, obviously, my answer must be between 3 and 4. It must be in this gap right here, between 64 and 256 is where 132 falls. So now we run into an issue. That means our answer is going to be a decimal or a fraction. And so we need to be able to find exactly what power you take 4 to get 132. So as of right now, we could guess and check and continually get closer and closer and closer. But I don't want to go through all that work. So let's look at what options we have. There's a formula or property about logarithms that will help us here. It's called the change of base formula. And you see here what the change of base formula says. If you have log base a of x, you can rewrite that as the log of x divided by the log of a. And so for the purposes of this class, I've eliminated the base from the log. And as we talked about yesterday, if there's no base on the log, we assume that base is base 10. And so therefore, what this says is we had a log of base a. We changed that into two separate logs, base 10. And we took the log of the x divided by the log of the a. That's where those numbers are coming from. So this formula allows us to do something that's going to make most of you happy. We're able to start doing all the logarithms in our calculator, not just log base 10. Because we can go back to our problem, log base 4 of 132, and we can write that out as log of 132 divided by log of 4. That's what the change of base formula tells us we can do. So now we can plug that in your calculator. Be careful with your calculator, because when you type in the log button, it's going to give you a parenthesis. So you need to make sure you close the parenthesis before you divide. And that works out to approximately 3.522. I rounded to 3 decimal places. You'll always want to round to at least 3 decimal places when working with logarithms, because we're talking about powers, and we've talked about exponential growth here and how numbers change in a very fast way with exponential growth. Well, if you only round to 1 decimal place, your answer could be off by quite a bit when you go to check it. Because remember, this is that connection down here. We're connecting exponentials to logarithms, because if we're saying log base 4 of 132 equals 3.522, then that means, so we said 4 to what power? Well, 4 to the 3.522 power should equal 132. And if you type in your calculator, it's like 131.9 something. So that does work. So this is a change of base formula that allows us to find the logarithms of any base in the calculator. These 3 properties you see here on your screen are extremely important that you have in your notes. We're going to spend over the next week, week and a half, we'll use all of these properties on almost a daily basis. So it is important that you have these down. What these do is these are properties for expanding and condensing logarithms. It allows us to take a logarithm where you have a multiplication inside of the log. This is why we call it the product property. There's a multiplication inside of the log. And that says we can write it out as 2 separate logs, where we can use log of x, log of y, but it becomes an addition when you separate that into 2 separate logs. The quotient property says if we're taking the log of x divided by y, you can again write it as 2 separate logs, log x, log y, but the division turns into a subtraction when you split it into 2 separate logs. And finally, the power property, the one that has a whole lot of influence when we get into solving exponential equations. This power property allows us to take any exponent we're taking a log of, and we can move that exponent into the front as a multiplication. So it becomes a times the log of x. That's going to be a very powerful tool going forward. To apply these properties, we're going to do expansion of logarithms today. We're going to take a single log and write it as multiple logs expanded out. So we're going to go through all the steps here, and we'll walk through this step by step for what you do for these types of problems. The first one, log base 3 of x squared y to the 5th. I have a multiplication, so I can rewrite that as log base 3 of x squared plus log base 3 of y to the 5th. When I'm expanding, I'm taking a single logarithm and writing it as multiple logarithms. This is not my completed solution, however, because I have these exponents, the 2 and the 5, that I can do something with as well. My power property says those can move in front as a multiplication, so I get 2 times the log base 3 of x plus 5 times the log base 3 of y. That would be my final solution for expanding that logarithm. I write it out in expanded form as an addition, and then move the exponents out front using the product property. I'm sorry, that would be the power property. We use the product property to write it as addition. So for the second one, you notice here that there's exponents on exponents, and there's a couple different ways you can go about doing this. I'm going to use the logarithmic properties to do this. We have a parenthesis to the third power, so that tells me I need to deal with that first. This 3 can go out in front of the log. That is our power property. So we have 3 times the log base 4 of x squared over y to the 4th. Then, I need to make that into multiple logs. The 3 applies to everything, so therefore I'm going to put a parenthesis around it because that third power applied to both the x squared and the y to the 4th. So when I split it up, I need to make sure it applies to the x and the y. We use a parenthesis to do that. So I use my quotient rule to expand my logarithm. And again, same as the previous problem, these exponents can be expanded more. That 2 can come in front of the log base 4 of x. The 4 comes in front of the log base 4 of y. From here, you can finish the problem by distributing the 3, making your answer 6 times the log base 4 of x minus 12 times the log base 4 of y. And again, that parenthesis made sure that the 3 went to both the log of x and the log of y. So this is called expanding logarithms. You'll come across some problems like radicals today where you're going to have to remember some of your rules, that a square root is also a 1/2 power, and we're going to see how well you do with some of those, and I will be around to help you.